Okay, in this question, you're asked to plot a graph of weight against mass. We always plot y against x. So in this case, your vertical axis, your y will be your weight, and your x-axis will be mass. So if you look at the diagram, you look at the graph that you have to plot, please take note. In this case, the A has been given for you, the axis has been drawn for you, okay? And the scale that you should be using in this case is an interval of 1 for your vertical axis. So 1, 2, 3, 4. And the x-axis is also a scale of 1. So this is a pretty easy graph to plot. And after plotting the graph, you are supposed to draw a line of best fit. Now this is the slightly more challenging part, because you notice that there will not be a line that will pass through all the points. So that's when you have to move your ruler around to make sure that the line that you eventually draw is such that it's very close to the points, and at the same time, for those points that are not on the line, they are quite well distributed above and below the line. So this is the line of best fit. So why do I say so? Can you see there is one point that's above this line? There's another point that's above this line. This is okay because these are experimental data. So you expect that you will not form a very straight line. But you, at the same time, you also have 2 points here that are below the line. So that means you have chosen the right line to draw, because this line distributes the points quite evenly. We also have 2 points that's exactly on the line. So this is a line of best fit. But if you have chosen to draw another line, and then the points that are not on the line are all segregated on one side of the graph, then you will not score mark for line of best fit. And so this is the graph, and you're asked to find gradient. So to find gradient, let me just erase this first. So to find gradient, what you need to do is to first of all choose 2 points that are far away from the line. So I've chosen this point. I'm going to darken it so you can see. I've chosen this point and another point here. You can choose any 2 points as long as they are far apart and it's easy to read the coordinates. Even if you have chosen, let's say, somewhere here, your answer should be not much difference from mine. So I've chosen this point. In reality, I will not want to darken it this way, so I will clean it off now. It's just to show you. And after that, I will write the coordinates of the points to show the marker that this is the point I've chosen. Okay, so I will write the coordinates. You always write x first and then you will write y. So in this case, I call this my x1, y1. So the coordinate of this point. And then I choose another point that's below here, and that's my x2, y2. And after that, I will draw a dotted triangle to show the location of these 2 points. Because after I draw a dotted triangle, then I know that, oh, this is where my gradient points are for me to determine gradient. I cannot emphasize enough how important it is to show this dotted triangle. I know in math, you do not have to show this. In math, you just choose the first and the last point and substitute into the formula. But do note that in math, your points are derived from a formula. So they will always, the straight line will always pass through this point. But in this case, these are experimental data, so you can't do it this way. Okay. So after I've gotten the values for x1, y1, x2, y2, I then come over to this side and I will substitute them into the formula. Be very careful when you do substitution, and I'll get an answer of 1.67. So the working on the graph will give you your 1 mark here, and the working subsequently will give you another mark for gradient. And then the question asks, what is the weight when the mass is 3.5 kilogram? So to do that, I will again show my working on the graph. So this is 3.5. I will always have to show this. And then I draw a dotted line up. And once I touch the graph, I will show the working again, and that's 5.8. Again, my working has to be very clearly shown. My values are written quite clearly on the graph. So that's 5.8 newtons. Okay, not to forget, because they want you to determine the weight, and the axis is in Newton. The unit is in newtons. And this is another part where you need to substitute the values. Don't worry if I've never seen this formula, it's perfectly all right. All you need is to substitute the value that you have calculated just now for gradient. You should get an answer that's quite close to 10. And the last part of this question says an astronaut jumps out on the moon. So what is the energy conversion? So the reason why he is able to jump up, that means the body has energy. So where does the body's energy come from? The body's energy comes from the food that you eat, because the food gives you energy, right? So and the food, the energy that the food gives you is stored as chemical potential energy. So so in this case, it's chemical potential. And when you jump up, you are actually at a certain height above the ground. So the moment you are above the ground, you will have GPE. So it has been converted to gravitational potential energy. And now the same astronaut jumps on the Earth. So what is the effect on the resultant force exerted on the astronaut? When the astronaut jumps on the Earth, the difference is that the Earth will pull it down with a larger gravitational force. So you will, okay, so the gravitational force on the Earth is going to be larger compared to before. And so this is going to be a larger force. So let's say your upward force is still the same, but now your downward force will be less. Okay. So actually, in this case, the resultant force will decrease, but because your gravitational force will increase. Okay, your resultant force means your upward force minus your gravitational force. Okay, so your resultant force will actually decrease, because if you are jumping up with the same upward force, but now your downward force is larger, so your resultant force will decrease. And that's because your gravitational force actually becomes larger. And because the Earth has a larger gravitational field strength than the Moon, right? So all the best for your exams. Go on to try the other questions in the revision package. The more you practice, the better your results.